All right, so we're going to look at some geometry problems that have shown up on the written round of last couple of years at Mathletics, DPS Mathletics competitions. So I'm not going to go fully in depth in all of the concepts. I'll just sort of touch over them. And if you have questions on them, like 30-60 right triangles or something like that, then please bring it up in class when you get back. All right, so a square has an area of 169. What is the perimeter of the square? Well, we know a square has the same side lengths, right? So we know that x times x is x squared, so x squared is 169, and the square root of x, take the square root of 169, and so we get x is equal to 13, because 13 is the square root of 169. You really should have your square roots memorized at least, or you should know the perfect squares at least for the first 20 perfect squares, maybe more. If the diagonal of a square is 5 root 2, what is the area of the square? Well, it's going to be 25. But the reason why I can do that so quickly is because if I were to draw a rectangle or a square, draw the diagonal, and I know that's 5 root 2. I realize that I'm creating a 45 right triangle, or an isosceles right triangle. And in an isosceles right triangle, we're going to call this side length A. Well, then this side length is also A because it's an isosceles triangle and these sides are congruent. And the hypotenuse is A times the square root of 2. Well, going back to my actual question, if this diagonal is 5 root 2, that means that this side length is 5 and this side length is 5. Therefore, my area is 25. All right, the diagonals of a square each measure 22. What is the area of the square? So I may not be doing this the most efficient way, but here's how I would approach the problem. The first thing I would do is I would draw the square. And I know that this is 22. So this side has to be 22 divided by the square root of 2. I'm not going to worry about rationalizing the denominator right now because I'm just trying to find the area of the square. And I know that the area of the square is going to be this squared, which will get rid of my irrational denominator, so that's why I'm not dealing with it. So 22 squared is going to be 484, I think. See, that's why it's helpful to know these. Divided by 2. And so 484 divided by 2 is 242. Now, I'm just going to double check this because there's a reasonable degree, possibility in my old age that I'm getting this wrong. So 22, that's 44, all right, divided by 2. All right, so there we go. That's the area of the square. All right, in the next problem, find the volume of a square pyramid whose base edges are 15 and a height of 10. Well, you know that the volume of a pyramid is going to be length times width times height, and you're going to divide that by 3 because it's a pyramid, not a rectangular prism. So we are going to find, so if I have a square pyramid, so I know that the base edges are going to be 15. So we have 15 times 15 times a height of 10, and we're going to divide this by 3. Okay, well, 15 divided by 3, that's 5. So I have 5 times 15, which is 45. 45 times 10 is 450. All right, number 7. Find the volume of a sphere whose surface area is 144 pi. Well, we know that we need to know two things for this. First, we need to know that the volume of a sphere is, it almost looks like a smiley face, is equal to 4/3 pi r to the 3rd power. We also need to know that the surface area, try to make a nicer one, of a sphere is equal to 4 pi r squared. And we're being told that the surface area is 144. So that's equal to 4 pi r squared. divided by 4, divided by 4, so we get 64 pi. Obviously the pi's cancel out, so we get 64 is equal to r squared, so r is equal to 8. Well, now let's plug that into our volume equation. 8 times 8 times 8 is going to be 64 times 8. So we have volume is equal to 4/3 times 5/12 times pi. And since we're giving the answer in pi, we don't need to reconcile that. So we're going to divide this by 3. So 3 goes into that once, 7, are you kidding me? So I must be doing something wrong here because this has to go in, right? So let's double check. So 144 divided by 4. Oh, it's 36. Crap. Sorry, I didn't mean to swear. So we have 36. So 36 is equal to r squared, so our radius is 6. That's going to make more sense. So 6 times 6 times 6 is 216. Just proving it here. I know you're not at calculators, but I'm trying to go quickly here. So we get 4/3 times 216 pi. And now 3 goes into that, right? So 3 goes into that 7 times. So we have 72 times 4. 72 times 4 is equal to 288 pi. And yes, you need to include the pi because it's in terms of pi. All right. Okay, last 3. What is the volume of a pyramid whose rectangular bases are, all right. So, pyramid again, length times width times height divided by 3. So we have 8 times 9 times 12 divided by 3. To make life a little bit easier for us, I'm going to divide this by 3, so we get 4. So we get 8 times 9 times 4. So we get 72 times 4, which is going to be 288. Isn't that convenient? Number 5. What is the volume of a pyramid whose base is 4 by 8? Same problem. So we get 4 times 8 times 21 divided by 3. So that's 7. So I get 56, because it's 8 times 7 is 56, times 4. So we get 4, 2. There we go. For number 10, find the surface area of a sphere whose volume is 972 pi. All right. So surface area. So first thing, so it says the volume is that. All right. So we get 972 is equal to 4/3 pi r to the third. So the opposite of multiplying by 4/3 pi is multiplying by 3/4. So I need to multiply this by 3/4. Okay, so 4 goes into 9 twice, carry the 1. 4 goes into 17 4 times, carry the 1, 3. And so now I need to multiply this by 3. So I get, do it over here, 9, 12, carry the 1, 6 plus 1 I carried. So we get 679, and lo and behold, 679 is a cubic number. I'm pretty sure that that is equal to 9. Now I'll prove it here. I'll go 9 times 9 times 9. Lo and behold, that's what we get. So we know that 9 is my radius. So then, now I need to find the surface area, and the surface area is just 4 pi r squared, so we get 4 times 81, so that is 4 pi. So there we go. That is the first page untangled.